Hello again. 9.2 angles in a polygon. In this video, we're going to be talking about the sum of the interior angles of a polygon and the sum of the exterior angles of a polygon. So first off, we're going to talk about the interior angles of a convex polygon. By drawing diagonals from a single vertex, we can cut the following n-sided polygons into triangles, and we can actually create a formula for our own for how to find the sum of all the angles. So any polygon we draw, any convex polygon, we can cut into triangles. If it's a four-sided figure, we can cut it into 1, 2 triangles. If it's a five-sided figure, by drawing diagonals from a single vertex, we can cut it into 1, 2, 3 triangles. And if it has 6 sides, 1, 2, 3, 4 triangles. You could probably guess if it had 7 sides, it would cut it into 5 triangles. So since we know the sum of the interior angles of a triangle, we can figure out the sum of the interior angles of any other shape, just based on how many triangles they have, right? If this four-sided shape had 2 triangles, each with 180 degrees, right? Then that would be a total of 360. This one has 3 triangles, each with 180 degrees. This one has 4 triangles, each with 180 degrees. Basically, the sum of the interior angles of any n-gon is just going to be n minus 2 times 180. This n minus 2 for the number of sides, right? If I had 6 sides minus 2, that was 4 triangles. And that 180 is the number of degrees in the triangle. It's literally just finding how many triangles are in an n-sided figure. There will always be n minus 2 triangles. Each of those triangles has 180 degrees. So the total sum is n minus 2 times 180. Next slide just has that shown again because it's a really important thing. You should memorize that formula. No, I said that really weird. Formula. All right, so you should memorize that formula. 180 times n minus 2, or the other way around, n minus 2 times 180, because multiplication is commutative. All right, there is a note here. While slightly more complicated to prove, the formula does still hold true for concave polygons. We just aren't caring so much about concave polygons in this book. They don't really show up a lot. So side note, it works for concave polygons, but we're not going to be using concave polygons a whole lot. All right. The exterior angles of a convex polygon. We should talk about the exterior angles for just a minute. I'm going to make some random polygon. An exterior angle is formed when I extend one of the sides and then I have an angle on the outside. That is an exterior angle. Now, we should note when we talk about the sum of the exterior angles, we got to have a set of exterior angles. And when we have a set, they all have to kind of rotate in the same order. So like if I continued that same rotation, had an exterior angle there, and there, and there, and there, those would be all of the exterior angles in one set. 1, 2, 3, 4, 5 exterior angles for a pentagon. If I did a shape like this, 1, 2, 3, 4, 5, and I said there's an exterior angle, and then I extended this one and said there's an exterior angle, and maybe there, and maybe there, and maybe I'll extend this one. So you can see that we're going to cause all sorts of problems. So exterior angles, they kind of go in a rotation like that, always on the outside. That's a set of exterior angles. We're going to talk about the sum of those types of angles. All right, so here's a diagram that shows the exterior angles of a hexagon. Normally I have students work through their sum. They kind of struggle at first because you don't know any of these individual angles. However, it turns out that it really doesn't matter, those individual angles, because whatever they are, I'm going to call them 1, 2, 3, 4, 5, and 6. I know when I take them and I talk about the exterior angle that's matched with it, those would always add up to 180. So all of those angles that I'm highlighting in purple all the way across, they're 180. How many of them do I have? I have 6 of them. So if I wanted to find their sum, I could say, well, I've got 6 pairs of 180 degree angles, for those straight angles. But then I need to take away these ones because those really aren't exterior angles. So I have to take away those angles. And that's not a problem because those are all the interior angles. And I know how to find the sum of the interior angles. The interior angles is n minus 2 times 180. So if I wanted to find the sum, it would be 6 times 180. Subtract n minus 2 would be 4 in this case, because that's a hexagon, times 180. Well, 6 times 180 minus 4 times 180, that'll be the same as 2 times 180, which is 360 degrees. Now that seems like a lot of work to go through every time, but turns out it's not going to matter how many sides my polygon has. If I had 7 sides, the formula would have been 7 times 180 minus the sum of the interior angles of a heptagon would be 5 times 180. And guess what that ends up being? 7 minus 5 is 2. That's 2 times 180, which is also 360. If I had 8 sides, guess what the sum of the exterior angles would be? 360 every time. There it is. The sum of the exterior angles of any n-sided polygon is 360 degrees every time. I'll make some star pattern on this as well. It's important. You should probably memorize that. There you go. All right. Again, while a bit more complicated, this does hold true for concave polygons, assuming you're willing to assign a negative degree value, which is weird. Again, our book doesn't really deal with concave polygons, so no worries. We're going to only be dealing with convex mostly. All right. That's it. Next video is on polygon area.